Good morning to everybody. Today we have a very particular task, and the task is something that is really essential for you in order to approach the possibility to analyze your own data. And in order to analyze your own data, of course, you need to understand how to download these kind of open source satellite data. So I mean, from here we are starting from the scratch, and so that means that we will face two different data. The first data that I want to introduce you is the Sentinel constellation, that is the European Space Agency constellation. And then after this first part, we will take into account the classical Landsat constellation, that is the NASA, the American one. So from here, we need to connect to the two different portals for Sentinel and for the Landsat that are already tailored in order to use this data and to download this data. In order to start with Copernicus, the possibility to start from here, it's already in my memory. So you see that in order to start, we are accessing this site here, that is the shehub.copernicus.eu. Copernicus is the general program that is managed by the European Commission. That is, I mean, it's foresee two different components. The first one is the satellite component, so the constellation of different satellites that is operated on behalf of the European Commission by ESA. ESA stands for European Space Agency, while the second component are the data and the different services that are established in the framework of the Copernicus different services. This is managed directly by the European Commission, giving the service, for example, for the emergency mapping or for the security mapping, land, maritime, and so on, to different providers of this information. All right. Now we are taking into consideration only the first component. The first component is related to the satellite constellation. So here is Copernicus, and SHE-HUB stands for scientific hub. So here you can find different kind of information. For example, here you see you have the different constellations or satellites that are available. You see in the framework of the Copernicus satellites, these Copernicus satellites are called Sentinel-1, Sentinel-2, Sentinel-3, and Sentinel-5P. We are still waiting Sentinel-4 that is forecast to be launched in next years. And I mean, these are the description of the different satellites. You have here also the user guide in order to understand whatever you need to know concerning the satellites and the data. And then you see here you have different components, and we will see this main one, that is the Open Hub, that you see and you can read here, is the access to all Sentinel missions data through the interactive graphical user interface. That is what we want to use and we're going to use later on. Here we have also API Hub, so that are possible. I mean, these are a sort of pieces of modules that you can install on your, for example, mobile, on your application in internet, if you are a regular users of this data. For example, if you want to use Sentinel data as background of a navigation view in your own application, you can use this API hub in order to access directly to the data. Then here you have the access of this Sentinel-5P that is a very different satellites because it's particularly devoted to the acquisition of data relating to atmosphere, and in particular in order to check emissions and chemical compounds in the troposphere. And then here you have also here the pod pre-operational products. So that means that I mean you can access to simplified data, but we will concentrate on this open hub. But before going to this open hub, let's see also the different here information that you have. These are latest news, but this is not very important from our case. But here in reports and SARS, it's quite impressive, these numbers, because you see that the product that are published in the last 24 hours, and products means images, or let's say some simply processing of these images, you see that every 24 hours, more than 30,000 different products and mailing our images are product. And then you see that the downloads in the last 24 hours are more than 200,000. You see? So, I mean, this is a very impressive quantity of data and access. And if I'm just pressing there in reports, this is more impressive because you see, we have this quantity of registered users that is not too much. This is not too much. So we are, the European Commission is still having some strategy in order to improve the quantity of registered users. But you see, what is very impressive, and this is why this archive is the huge and is the most, the bigger big data archive in Europe, is that this quantity of data here. You see that from the beginning, that means from 2012, we have almost 300 picobytes of data. It's an impressive quantity of data. And you see that still now, there are more than 30 million images available worldwide in this archive. And you see open access hub availability over the past month is 99.4%. So that means that I mean, all these data are available in the majority as open access. So, I mean, they are free of charge data, all right? And here you have also the different annual reports from all this data. So let's go back here and let's just have some information that are coming from this user guide. So we can click here on the user guide, and on this user guide, you have all the different information that maybe you can download in order to have more information. Then, in addition to what I'm saying to you, that is the strict necessary in order to download the data. And you see that the data that you can access are Sentinel-1 data, and this is the offer that you have on Sentinel-1 data. But consider that Sentinel-1 data are related to active sensors. So they are radar images. We didn't talk about radar images because we don't have any time. These are very complicated to use, and so don't use this data. I mean, you will use that if you will continue to keep on remote sensing, but not for this course, because otherwise, I mean, we need the double of time that we already spent in this course. So don't consider Sentinel-1 data that is a couple of satellites over the same orbits that is acquiring in an active mode. So that means using radars in the microwave bands. Well, and where we are really interested in, instead of Sentinel-2 data offer. The Sentinel-2 data offer is a passive sensor that is acquiring a very good resolution. And you see we have two different data level. And just to have some information, this is the level 1C and the level 2A. And this is very important to know in order then to download a very important product. And this is of these Sentinel-2 data are both like Sentinel-1, a couple of satellites over the same orbits. So I mean, it's able to have a temporal revisiting, so a temporal resolution that is close to a few days over the same area. Of course, it's depending on the latitude of the area you want to acquire. Then you have also Sentinel-3. Sentinel-3 is another passive system that is working as Sentinel-2 in the optical windows. This kind of data has a very lower geometric resolution, so that means that it has a very large SWOT, so they're acquiring very large areas, and due to this fact, the temporal resolution is very low. It's very high, I'm sorry. So they are able to acquire more than one image every single day. And this is the Sentinel-5P data offer, and Sentinel-5P is used for atmospherical analysis. So out of all this data, I just give you information about, and we will download that, only Sentinel-2 data. In order to understand what kind of data we are approaching, apart from what you have already available on the folder of the data that you have of the Dropbox folder that is accessible to you, let's check what kind of level of processing data we are available on this portal. So simply click on one of these two links, and here we are going to the description of these Sentinel-2 data. I remind you that there are a couple of satellites, and these couple of satellites are carrying on board the same sensor. This sensor is called MSI. You see, MSI stands for Multispectral Instruments, very generic acronym. All right, here you have the Sentinel-2 user guide. I don't want to keep that in consideration. But what is very important is just to have a very brief description of these instruments, these MSI instruments. So click here, and you see what is very important is to have a list of spectral bands. And you see that these Sentinel, and there are two satellites, as I mentioned before, on the same orbit. The first is called, as an acronym, S2A, Sentinel-2A version, and the second is Sentinel-2B, so S2B. And you see that they have 13 different bands, because you see we have 8 and 8A, so we have 13 different bands. Here is the central wavelength, and you see the two satellites are more or less the same. They change really very part of microns in the central wavelengths, but they are more or less similar. And you see this is the bandwidth, so the see how is wide every single band. But what is very important is the fact that we have different spatial resolution. So I mean, for example, you see the highest spatial resolution is devoted to band 2, 3, 4, and you see here 8. And of course, these two bands are the 2 is the blue, you see here, the 3 is the green, the 4 is the red, the 8 is the near infrared, all at 10 meters. Then you have other bands that are acquired at 20 meters. So you see here, for example, band 5 and 6 and 7 that are bands you see here that are both in the red edge, just passing from the red to the near infrared. You see we have 3 different bands here. Then we have also a 20-meter bands here, the 8A, that is again in the near infrared. Then we have other 2 bands here that are the 11 and the 12 that you see 1.6 and 2.2 microns that are very similar to the Landsat bands 6 and 7 over the Landsat 8, and this is mid-infrared, you see here. Then there are also bands that are like 60 meters. The first one is the band 1, that is the blue, that is the ocean, that is used for ocean analysis, like in Landsat 8, is the same of band 1 of Landsat 8. Then you see here we have other two bands of 60 meters, that are these two one, the 0.9 and 1.3, that are both in the mid-infrared. All right, so this is the passive instruments. All right, and these are, you see, the description of the wavelengths. Then of course, and here you have also the scratch of the design of the sensor as is mounted on board of the satellites. And you see here you have also the different spectral bands divided in 10 meters, 20 meters, and 60 meters. All right. And then you have also, you see here, this is the visible and near infrared, and this is the mid infrared. All right. And then you have also some other bands that are also used in the thermal infrared. All right. So this is the description. Let's see the products and algorithm, because this is very important. I don't want to waste time here because you can then see that with more details by your own. But you see, level 1C and level 2A products, you see here, are made available to users via the Copernicus Open Access Hub, the SHE Hub, the page, the portal from where we are coming. All right. So what is the level 1C? Level 1C products provide auto-rectified top of the atmosphere reflectance. So that means that is georeferenced with a very good accuracy on the ground. And what you have in the digital number is what is technically called top of the atmosphere. TOA. What does it mean, top of the atmosphere, reflectance? What is registered outside the tropospheric layers. So that means that we have reflectance, you see here, but pay attention that we didn't have the correction, we don't have the correction of the selective scattering, because the selective scattering is corrected also in the level 2A, because the level 2A provides the same geometric correction of the first one, but you have here, you see, bottom of atmosphere, BOA reflectance. That means that is the reflectance that is measured on the Earth surface. So that means that is also and already corrected by the selective scattering. I'm sorry, I was losing my words. All right. So in our case, of course, it's better to access, if possible, to level 2A products. Not always are available, especially for archive images. But I mean, in any case, if we don't find any 2A products, we know that 1C should be corrected for the selective scattering, using, for example, the dark subtraction algorithm. All right, so we are here. So let's go back to the first windows here, Open Access Hub, and let's go to the Open Hub. So let's access to all Sentinel missions data through the interactive graphical user interface. So click on that. And when we are clicking on that, you see it's opening a very simple graphical user interface, what is called GUI, the GUI. And this is the graphical user interface. You see you have the different toponyms and the different states. You see you have a very simple map. And how you can find some images over here. I mean, the way in which you can find images is very, very simple. For example, let's just concentrate over maybe Torino, and then you can try to, for example, the city where you live or where you are connected from. And I'm just using the wheels on my mouse. I'm going here to Torino, and if I'm pressing the left button of the mouse, I can pan the image. You see, if I'm zooming in, of course, there are more details that are opening. You see here. So this is Torino, for example, and what I can do in order to find images over a particular area, the way is very simple. So you see here we have very few different buttons. For example, this one is habilitate the OpenStreetMap background. This is what we are using, but you can also have images and for example, terrain, if you want to have a look on that. I prefer to have this one, but you can pass from one to another without a simple click. And in order to define an area where you want to find the images, I mean, it's really simple here, because you are going to this icon here, you see switch to navigation mode. So when you are clicking on here, you see, now you can just draw a polygon. You see, I'm drawing a polygon here over Torino. This is the polygon where the search of data will be based on. All right. So how can I can find data? It's again very simple. You see here we have the insert search criteria. Don't put anything here. Just click over this menu. And clicking over this menu, you see you have different options. The first part of these windows is related to the general option. So you can sort by ingestion date, sensing date, Altai ID, considering that the ingestion date and the sensing date is more or less the same, because I mean the data is ingested a few hours after the sensing, so I mean ingestion date is okay. Order by descending or ascending. You remember what we mentioned about the orbits. I mean, from this point of view, we don't have any problem. It's the same. Here, you can set the period of sensing. So, for example, if we want to find data from, I'm recording this video in October 23rd. So, for example, I want to have data in the last month. So, starting with September 24 here and going to today, okay, the date in which I'm registering the data. Or you can also, and this is the sensing period that is the most important. The ingesting period is not so important, is when the data are available on the portal. All right? Is this interval here, this time interval here is important for us. So I'm searching data in the last month. All right? And here you can simply click on what data you need. Sentinel-1, that is the radar, Sentinel-2, that is the high resolution geometric data, and Sentinel-3, that is the low geometric resolution optical data. So in what we are interested in, of course, in Sentinel-2. So let's click the check here in Mission Sentinel-2, and then here you can also have more parameters. For example, here, satellite platforms. You can search for the first one, S2A, the A platform of Sentinel-2, or the B platform of Sentinel-2. If you are not putting anything, it will search over the two platforms. This is the best thing. Product type, this is very important. If you are not putting anything, okay, it will search for any possible products. Let's check if the data 2A is available. So data auto-rectified, very geometric, a very high geometric accuracy on the ground, and bottom of the atmosphere for digital number, so calibrated and thus subtracted. And then here you can also search the relative orbit, because you remember during the orbits, I also in the lectures, I also mentioned that is this reference system related to the orbital SWOT projected on the ground, but we don't know right now which is the right orbit. And here you can assume that you is searching only the images that are not too clouded. Remember that here we are facing a passive sensor that is working in the optical windows. And so, I mean, if there are clouds, you cannot see under the clouds. So, I mean, here we can, for example, put a limit, but for this first search, don't put any limit, all right? So we are searching in this area, Sentinel-2 data, bottom of the atmosphere and orthoprojected data acquired in the last month. All right. So in order to perform the search, simply click over the lens here. All right. You see, in order to perform the search, you need to log in. All right. And in order to log in, I'm already registered. If you are not, of course, you have to sign up. And signing up, I mean, I don't want to explain you how to sign up. You will put some information, an email, a valid email, and you can, of course, sign up in very few minutes. So in this case, I've already signed up. I have also a password. I'm logging in. All right. So logging in, you see now I'm registered and I'm working as Piero Boccardo right here. And now I can perform the search. All right. You see, is searching over all these petabytes of data. So I mean, there's a bunch of data to search for, and you see, it will take some time in order to find all these data. So just wait for what will return as results. All right, I did pause the recording, waiting for the results. Now the results are here, and you see we have many different data available. You see here, and these are all the data that are acquired in this area in the last month. So let's before everything, just to zoom out, and you see that we have some things here. You see that we have data and we have frame that are the SWOT of the images that are available. So you see, for example, I'm zooming just a little bit in. This is Torino. You see, unfortunately, Torino is really on in a corner of different acquisition of this scene here. Is out of this one, so it's in the upper right corner of this scene here. And also you see here we have a sort of strip. It's at top of the second strip. So I mean, unfortunately, Torino is always in a particular position. It's not really well centered in that image. So for example, let's see what is available. For example, you see this seems to be a very nice image. This is, of course, just a tumble of the image, so it's very under-sampled, and it seems not to be too many clouds in comparison with this one. You see, it's full of clouds. There's nothing. So when you have, you see here, you have the data, Sentinel-2, instrument MSI, and this data is acquired on the 13th of October 2020, local time 10:20, 10:19 in the morning. They are all passing at that latitude around 10:11, something like that. So this is acquired by the second platform of the Sentinel-2, the Sentinel-2B, with these instruments. And you see here we have different icons. The first icon is zoom to product. The second is view product details. And the third one is add products to cart. And then you see here, download the products. Very simple. If we are clicking over the first one, we are zooming to the product. So you see, zooming on the product, you see we are here. So it seems not to be in Torino. In order to be sure of that, we can just click on these things here. We product details. All right. When we are just seeing the product details, now is downloading a very low resolution version of this data, and it will present that in this image. You see, here it is. This is the image, and this is called technically quick look. That is an end assemble image that is enough in order to understand that I mean, that is very good for the cloud situation. You see, we have only something here and something here. But unfortunately, you see, Torino is not here. It's out of this image. So, I mean, this is not interesting for me. So I can close these things here. And for example, I can go to this one. I'm getting up. I'm taking off the selection here, so it's not selected anymore, and I'm going to select this one. All right, where it is, it seems to be here, the second part of this acquisition. Let's check the details of the products. Let's check it. We need to wait sometimes in order to wait the portal to produce the data. You see, here it is. And you see, this is an image where we have very few clouds. And you see, up here, we have Torino. You see, it's here. And more or less, we have all the city of Torino. It's in this position, but it's okay. Okay, let's consider that this is the image that we want. You see, it's acquired again in the same day, okay, from the same satellite, all right, and at the same hour. So it's a piece of the image that is acquired over the same orbit. And if we want to have this data, it's very simple. You see here we have data, download products, and we can download it. All right, very simple. Is a zipped file, a folder in reality, that is 85 megabytes of data, 850 megabytes of data. We can simply tell them save this file. All right, so we are saving it. I'm putting that on my desktop, you see, and you see here now it's downloading the data. Today I don't have, this evening I don't have a very good connection, so you see I'm downloading only less than half a megabyte, around half a megabyte a second. So you see I need 20 minutes in order to download the data. But I mean, let's do the CPU do this hard job, and here is the way. So, for example, if you want to use another image, for example, this one, you see this one is characterized by all these part. Let's see if the product details is also encompassing Torino, for example. This is the same acquisition, because you see, these acquisitions are made of different pieces. They are acquired in the same day, in the same orbits, in the same hour. So, I mean, they are more or less always the same. Let's check if this larger image is encompassing also Torino City. Let's wait for the results. And you see, Torino, unfortunately, is on the border. We are very, I mean, this is really a pity that Torino is on the border. Of course, this is not the data we are looking for. You see, all the other data are very cloudy. You see from here. So, for example, here we have something that maybe could be interesting. Let's check this one that is acquired the 8th of October. And you see, after 3 days, more or less, they are acquiring data. Let's check what kind of data is that one. I think that is the same. Let's check if the same as the other. If Torino is again on the border. Let's generate this file, and you see it's the same. It's the same scene. You see? Okay, let's close it. Let's check this one. Let's view, let's have this image. Let's give up these things here. And this is the other image. So you see that, I mean, Torino is it's always on that strips here. We have other data here. We have also a second page of data. Let's check this second page. But I mean, I don't think there are much more than what we have already found it. I mean, it's the same data as before. So, I mean, maybe this is the only available image that is not so clouded, because we have other images acquired on the let's say on the 18th of October, and also the 8th of October and the 15th of October, but I mean also 11, but more they are all cloudy in that area. So you see that also from here you can understand that, for example, in October, that is a very rainy season in Torino. This is the new available data here. I mean, it's not really simple to find images that are not covered by clouds. All right, so for example, let's check which is this one. Okay, maybe this one could be the right one that is acquired on the 26th of September. Let's check it. It seems to be a little bit cloudy. Okay, Torino is there. So this is snow. All right, that was a really at that time in this area there was a flood. So I mean snow in the mountains here in Torino. So this is another good image to be downloaded. So that means that we will have a couple of images that are representing Torino. So we can also perform multi-temporal analysis. So let's download also this one. All right, I will save this file. All right, of course, if I'm saving more than one file, you see, of course, I will get more time. So I mean, now I'm stopping the recording, and I will back to you once I will download everything from in my hard disk, and I will show you the results. Okay, see you later after the download.
All right, guys, we are back here. We finished, I hope, hopefully, the download of the two images. So let's check here in Firefox if we have everything. Okay, you see we have the two files. So I'm opening the folder here, and you see I have these two files related to the two images. So you see the name is very long. And I mean, the first one is the 26th of September 2020. This is the larger one. And you see it's more than 1 gigabytes. And the second one is, you can see here the date, the acquisition date, the 13th of October 2020. So let's open and I mean, first of all, we need to uncompress the file. So I mean, I'm just right-clicking on that, and I'm going to extract everything. And okay, I'm extract here, and I'm going and I'm proceeding with the extraction of all the different things. All right, you see that we have more than 140 different files in the same data, because there are many data that are referring to the quality data assessment of the different data. You see they are all very small data, because you see we download everything in very few seconds, and now we are starting with the larger raster files that are all the different bands, and you see we downloaded everything here. Okay, this is the first one, and now we are going to and I just can close these things here, and we can right now uncompress also the other one. So I'm going to extract everything in another directory, and you see we are going also to extract all this data. You see now is extracting the 20 meters bands, you see here, and now the 10 meters bands, you see. All right. Okay, it's finished. All right, so now we can just see how is the standard folder structure of this Sentinel-2 data. So let's open the uncompressed file. This is, again, you see the name is too long, and we will have problem in order to manage in Envy all these files. You will understand that afterwards. So let's open that, and you see we have, first of all, 5 different folders here. The auxiliary data, the data strip, Granule, HTML, repository info, and then 3 data that are XML, that are something that is related to the standards, to the standard used for the saving of the image. Where we can find our bands. Our bands are here, are in this subfolder that is called Granule. Let's double click on Granule, again the name of the file, and then you see here we have 3 other subfolders: auxiliary data, IMG data, and QI data, that are the quality indicator data. And then other file that is an XML file. Let's open that, for example. Yes, let's open with a notepad that you see there are all the information related to how the structure is. So you see, for example, here we have all the information in this file here, mtdtl, all the reference, a number of rows and lines for all the different images. For example, you see that the image with 10 meter resolution is more or less 11,000 by 11,000. The 20 meters are, of course, the half, that is 5,500 by 5,500, while the 60 meter resolution, you see, is less than 2,000 by 2,000. And this is also the geoposition resolution at 10 meters, so it is the upper left X, upper left Y, so that means the first cell of the image, upper left, and this is the position of the cell. And so, of course, knowing the position of the cell in the upper left corner of the image, and knowing the dimension in rows and columns of the image, of course, we can georeference every single cell of the image. You see, so here we have very, very interesting data. And these are the value list of the different bands. All right. So this is something that is related to the radiometric resolution. I'm sorry. All right. So the images are, of course, in the folder IMG data. Let's open that. You see, we have the 3 subfolders with 10 meters, 20 meters, and 60 meters. For example, 20 meters, you see, what we are interested in is these 4 different bands, the BO2, BO3, BO4, and BO8. The stands BO2 for the blue, BO3 for the green, BO4 for the red, and BO8 for the near infrared. And these are in JP2 format. It is a sort of JPEG with georeferencing information embedded in the file. So you see, we can understand that the meaning of these different bands here, while here we have other files that are representing some ancillary information. For example, this one that is, you see, is quite big, is the TCI 10 meters. It's the already prepared color composite image. So this is a true color in the visible image, already ready to be used. But I mean, we really don't need this file here. All right. So for the other files, it's all the same. And for example, if we are going to the 20 meters, you see we have more bands. For example, you see here we have the B2, BO3, BO4, BO5, B7, 6, 7, 8A, 11, 12, and so on. Because, I mean, also the 2, 3, 4 and 8, like before, you see VO2 20 meters, we have both the version, both in 10 meters and 20 meters, all right? And then the last one is the 60 meters. 60 meters, you see we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 12. So we have all the bands at 60 meters also of resolution, undersampled from the geometric point of view. All right, very good. So now we can close that. We can also close these things here, and we can go to ENVI just to understand how we can open this file. So I'm starting the 64 bits version of ENVI, and you will understand as soon as we try to open that unfortunately we have, with this version of ENVI, the 5.3, we will have some problem in opening this file. So I'm just closing a little bit the toolbox. All right, how we can open this file? Of course, we have this possibility, file, open as, you see, optical sensor, and you see that we have here Sentinel-2 option. So we are going for to Sentinel-2 option, all right? And so here we are waiting to open a file as the instruction here, an XML1, all right? So let's go to the where I put the data. Is, for example, the first one here. You see the name are quite long, and you see we have possible files here. I assume that it's not here. Let me check if, for example, it's this one that is referring to the format, to the bottom of the atmosphere of option. I'm trying to open. Okay, you see it's not the right one. So now we can try to open as a Sentinel data optical sensor, and we are going to Sentinel-2, and we can go again from here in download. Let's open the first one. I'm sorry, here. Let's go to the granule, and to the granule, you see we have this folder, and let's try, for example, this file that you remember we did open that with the notepad, and this is a file that is describing the different bands. Okay, let's try to open that, and you see also this one is not opened by the software. So I mean, there's a problem in this version of the ENVI 5.3. I'm sorry. Because before, when this version of the ENVI was issued some years ago, the data that you can at that time you were allowed to download from the Copernicus sites were in a different formats. Then they changed that, and now in this version of ENVI you don't have the possibility to open that. Consider that with the ENVI 5.4, you can open this file without any problem. So in order to face this problem, we have two different options. The first option is to use a software that is delivered directly from the European Commission in the framework of the Copernicus program. That is an open source software that is, processing remotely sensed data, and in particular, of course, Sentinel data. And you can, for example, download this software, but this is not the right way, because you have to download a whole software, using that only just to download the image from this folder structure. So it's not really the good way to do. So let's try to solve this problem using ENVI. So when we are using ENVI, of course, we cannot open with this function. So we can open like a very normal file. So let's open that with the icon of the folder. Let's go to the image data. Let's open the 10 meters first. And you see we are not opening everything. We are opening only band 2, band 3, band 4, and band 8. That are the 4 bands at 10 meters. You remember? I can go here. All right. So MSI instruments. So you see at 10 meters we have these 4 bands. This one, and this one. And then also this one at 0.8, that is a near infrared, okay? And we have also the central wavelengths for the S2B, that is the actual sensor we are using, all right? The platform that we are using for this download, all right? So we can simply open these files like that. And you see that it's working. I mean, all the files are there. You see, these are the files. And the only problem is that files are singular. I mean, they are all separated. You see, so if I'm going to check everything here, you see they are all divided in different sections. And you remember that Torino was really in the upper position of these things here. I have the feeling that it's here. You see here, he is Torino. This is the B08. This is the false color. This is the near infrared, and you see that is Torino at 10 meters. You see, in near infrared. So, for example, if you want to have a look to Torino in true color image, in RGB associating of course, the red, green, and blue bands, what we can do? We can go to the data manager, and perform a band selection where we are associating to the red band the band number 4, that is the visible, this one. To the green we are associating the band 3, and to the blue we are associating the band 2. Okay, let's load the data on the same views, and you see this is Torino, and we can, for example, have a Gaussian. This is Torino, you see? It's very good, 10 meters on the ground, not bad this data. You see, we have also the different football stadium here. This is the stadium, this is where the Torino football team is playing, while, for example, the Juventus is playing in another one that is here, you see? Here it is. This is the Juventus stadium, you see, with all the structure. So, 10 meters, you see, is not bad at all. And, for example, we can also show with the data manager also the false color, and the false color is to the red, the infrared, to the green channel, the red, and to the blue channel, the green. Load this data, all right, here it is. Let's also have a Gaussian stretching. And you see this is the false color. In red, of course, all the vegetation. So you see these are data completely free of charge, and they are very useful. All right. So we can do, for example, the same things with the 20 meters. But before doing that, maybe we can do another things. So unfortunately, for example, if we want to extract a region of interest from here. We are also working on one single file. So, because these files are not in the same file, in the same, let's say, container. So we need to encompass all these bands in a unique file. And we can do that. You remember, we are here in the raster management. We can use you remember the last lab, so we can use the layer stacking. All right, so double click here on the layer stacking, and here as you remember, we can import the file. And in order to import the file, we should open that before, of course, like we did. So we can import these files. Maybe we can import all these different files, you see. So we are selecting everything. We are using the full scene, for example, and we can just simply click OK. All right. And you see here, I know that. You see, there's an error because here the problem is that the input file must be georeferenced. So that's a problem. Why is not georeferenced this file? Because there is the georeferenciation, but unfortunately. When are you reading that? You see that here we have that. You see, we have the coordinates in this position, but unfortunately, it's not in the header file. The header is a text file that is coming together with the image matrix. So I mean, what we can do is just to check if we can edit the header file. So for example, let's go to the band 8 and let's check if we can view the metadata. You remember we did that. So we are starting with let's do in order. Let's start with the first band, that is the blue band, the BO2, that is bottom of the list. Right click with the mouse and let's go to the view metadata. Okay, you remember here, view metadata, we have this map info. And you see map info seems to be there because you see the position, the first point has these coordinates. Okay, upper left. This is the same we read in the notepad, in the XML file, you remember? But I mean, seems not to be there. So let's click here on edit metadata. And you see here we have all these different things. And when we are here, you see, we have these type points, okay? That is optional, all right? So if it's optional, we can open that from this data set, all right? So we are opening from this data set, all right? And now I think we can display the results, all right? Let's check if it's working, these things here. So press OK, and you see now this file is here. Let's just to try to reopen the layer stacking option. Let's import only this file here, that is the number, the BO2. Let's import only this one, and you see it's there. So I mean, it's a very trivial option. I mean, we need to go to every single file and to habilitate with the edit metadata the lecture for the layer stacking. It's of course a bug of the software in this version. I mean, we need to edit the metadata and just to add this information related to georeferencing. So let's cancel this option because we need to do that also for the other. So let's go to the band 3, right click, view metadata, edit metadata, and you see here we have these things here, and we can click OK. All right, that's enough. You see that now it's passing from here, from the bottom of the list to top of the list, because it's reading the georeferencing. Now it's georeferenced. It was. But I mean, now it's clear also for the other functions of Envy that is georeference. Let's do the same for band 4, view metadata, edit metadata, and simply click OK. And it's passing in the other part of the list, and also for the other. So view metadata, edit metadata, and OK. All right. So now we are in the right position. So, I mean, we can now relaunch the layer stacking option, double click on that, import all the files that we have, and we are selecting everything, okay, and we are pressing OK. So you see, and pay attention, I already mentioned this problem last time when we are perform multi-temporal analysis. Pay attention to the order. Otherwise, I mean, if the order is not correct, I mean, we can have really a fuzz in the analysis. Because, I mean, for example, here, the list is band 3, 4, 8, 2. I mean, this is not the right order. So let's use the usual order from smaller to longer wavelengths. So let's reorder the file here, and we put the first one, drag and drop in the first position, in my case, and then I have B2, B3, B4, and B8. That's okay. We can press OK. All right. We need to choose to save the file. Let's choose it. All right. I can create, for example, a new directory here, a new folder. Okay. I'm creating a new folder here. Let's call that Sentinel test. All right. and we are putting that here in this new folder, and I'm calling that, I don't remember the acquisition date, okay, is this one. So let's write 2000 and 2020 1013, that is the acquisition date, and this is underscore the data set of 10 meter, all right, 10m dot, all right. This is the first data set, okay. I'm opening that, you see all the, in the right part of the windows, all the projection has been read by the layer stacking operations. I mean, is UTN, WGS 84 meters, 32 diffuse north, and the resolution is 10 meter. All right, let's press OK. And now it's building the stacking. So now we have to wait a little bit because, I mean, you see these images are not so quite huge. So, I mean, it's reading the JPEG format, and now is resaving that in the MV internal format. So, I mean, that's why it's taking too much time. So you see, for example, this is only the input file 1 of 4. But we will wait, and maybe I will cut the recording, and we will back as soon as we have finished all the operation. All right, guys, and how you can see on the textual file. After a while, we are completing also the writing of the fourth band of our 10 meters dataset. That is the near infrared one. Is finishing that, and so after this quite long operation, we will have the availability of all the data. You see here, now we have this data, and you see here is, let's use the Gaussian. The Gaussian one, you see, as usual, when you have a multispectral data, is using these bands, the first three bands, in the opposite order by default in order to display a visible bands, all right? So now the dataset is ready, and we can use this dataset. Of course, from now on, whatever you are doing, you see, let's go to the data manager. At the end of the list, you see, we have this file that is encompassing all the four different bands. So from now on, whatever you are doing, whatever procedure you are doing, from, the density slicing, till to the extraction of ROI, till to the filtering, till to the classification, they will be done on all these different bands all together. So if we are extracting ROIs, and we will use that in the next part of this lab, we are extracting a sort of spectral signature, if we are using these things here, that is showing you how this particular surface is reflecting in the visible and, of course, in the near infrared in this case. All right. So in order to do and to prepare also the other data, we can do the same exact thing of before. So we are opening, and we are going to the 10 meters resolution data, and you see the 10 meters resolution data have more spectral bands. Band 2, 3, 4, 5, 6, 7, 8A, B11, B12. All right. The other one are other different bands. Don't open that. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 bands. Let's check on here how many bands we have. You see, we have this one, 1, 2, 3, 4, 5, 6. But we have also the other bands that actually before were in 10 meters. So they are resampled in 20 meters. So the 20 meters encompassing both 10 and original 20 meters data. All right. So 3, 4, 5, 6, 7, 8, 9, 10 bands. All right. So let's open that. Okay. And these are the data. This is 20 meters. This is B12, that is mid-infrared data. You see the resolution is worse than before, of course. And now we can prepare the same data as before. So starting with the first one, the B2, we are clicking, right-clicking with the mouse. We are going to the view metadata. We are editing that, and we are simply press OK. All right? And we are doing that for all the different bands. And when done that, we will launch again the layer stacking. So let's simulate that. I'm importing the first file, that is this one, top of the list. Let me check, is the BO2, this one. All right. I'm taking OK. You see, it was read from the layer stacking. So we need to redo the same exact thing of the 10 meters dataset. Now I'm stopping the recording. I'm performing out of the recording of this operation. And when I will launch the layer stacking, and when I will load the last band, the B12, remember to reorder the different files in the layer stacking. I will restart the recording of this video in order to not to waste your time, in order to present you some sequential things that you can do with your own. So I'm closing this video, and we will start again when I'm going to finish the layer stacking for the 20 meters band. All right. So let's wait, and we will be back in a few minutes. All right, guys. So you see that I'm going to create the layer stacking for the 20 meters file. You see, it's quite quick, because the images are only more or less 5,000 by 5,000 every single bands. So it's read in a very quick way, and so it's finishing with these files here. All right. So you see here, once finished, we will have all the different data. So let's check it. This is, of course, again, let's go to the Gaussian one. You see, when is it's opening only this file. Let's say, I'm sorry, I was lost. All right, and you see we have all the 9 different files here, the 9 different bands here. You see. So, for example, if I want to just visualize, let's open again the data manager. If we want to visualize a true color, I need to open that in 20 meters. Okay, I'm adding to the red band 4, band 3, and band 2. I'm loading this data, and you see this is the visible in the true color at 20 meters. If we want to have the false colors as usual, let's open and exploding the band selection. Let's open, and of course also enlarging these windows. We are opening band 8A, that is the near infrared, and then 4 and 3. Let's load that, and you see, let's also perform a Gaussian equalization, and you see this is, of course, again the false color one. This is 20 meter. All right. So let's open the last data set. The last data set is the 60 meters. So we can do that all live, because the images are very, very small. So let's open band 1, 2, 3, 4, 5, 6, 7, 8, 1, B9, 11, 12, and 12. Okay, that's it. Okay, let's open it. All right. And now it's opening all the different files. You see, it's there. So again, you see that the resolution is very low. It's only 60 meters on the ground. So let's do the same thing as before. So we are starting with band 1, that is a blue one. This is the first one that we have this band. So right click on that, metadata, edit metadata, and OK. And let's do, I don't talk anymore. I will do that for all these different bands. You see how many bands we have? 2, 4, 6, 8, 10, 11. All right. So let's do that. I don't talk anymore. Okay, I'm finishing that. Okay, I have all the 11th band here, so I can relaunch the layer stacking. Now I'm importing all these files. That is the 60 meters files. Here they are. So I have, you see, all these different files. I'm using all the full scene, clicking OK, and then I choose where to save that. In Sentinel Test, I'm using again this file here, and I'm changing the resolution here, not 10 meters, but 60 meters. All right, I'm opening that and I'm pressing OK. I mean, you see that the layer stacking is very quick in this case. The images are very small. It's less than 2000 by 2000. All right, so let's go to the last data set here in the data manager. So if we want to see again a true color, I mean the true color will be 432. Let's open that. This is the true color. Let's go to the Gaussian. Of course, this is the resolution of the data. If we want to have a false color, the addition will be 8A43. All right, let's load the data, and you see, as usual, we have all these different data at the different resolution. So I mean, that's it. We can have everything in 3 different layer stacked files, and of course we can do, and you will do that also for the other file, for example, or for whatever you will download by your own. Because I mean, don't use this file that I'm downloaded, because that is not available on your folder in the Dropbox, because you need to download for your own a file that you will use for your practice. So download whatever you want. Maybe the first, I mean, the best thing is just to download the area where you live, or from where you are connected, or from an area where you are interested, and perform the same operation that I done in Torino in your dataset, and build these 3 layer stacking at 10, 20, and 60 meters, and having already downloaded another image, a multi-temporal one. These are very close to each other, but you can also download something that is maybe older than that, maybe 1, 2, 5, 10 years difference between the others. Of course, not in Sentinel, because in Sentinel you don't have all these historical archive, because Sentinel is a data that is available since a few years. But we will see later on that we can do the same things using, for example, older Landsat file. All right, so with Sentinel we're finished, and now we are starting the same procedure, starting with the description of the data in the portal of the NASA, the National Aerospace Administration of the United States, where all the Landsat data are stored. All right, so now we are in the phase of, we have finished to download and to prepare the Sentinel-2 data, and now we are going to download the Landsat data. How we can download the Landsat data? I open a new tab here, and in order to download this Landsat data, we need to go to the portal of the NASA, and this portal is called Earth Explorer. Earth Explorer USGS, you see, that stands for United States Geological Survey. So let's search for that, and you see we have Earth Explorer, and the link is earthexplorer.usgs.gov. All right, so let's go to Earth Explorer, and Earth Explorer, you see, is starting with also the GUI, the GUI, the Geographic User Interface, the graphic user interface that you see. It's centered in the place where this facility of the United States Geological Survey is placed. That is here in Sioux Falls, that is in the middle of nowhere, as you can see here in South Dakota. Just to have an idea, it's here. You see, it's in South Dakota. It's close to Minnesota and north to Nebraska and on the border of Iowa. So I mean, it's very cold there. There's nothing. I mean, South Dakota has very few inhabitants, and I mean, it's there. So I mean, you see here we are in this area here. Of course, again here in this portal of the USGS, you need to log in. If of course you will not have any user account, so you have to create a new account. That is really as Sentinel, as the CHAB portal is very easy. I already have an account here, and so I can sign in. So you create an account and then sign in with your account. All right. So we are here. How we can perform the search? So you see, enter search criteria, and in order to search, you see, pay attention, because here, or you can upload a shapefile or a KML, and that will be a point, a line, or an area. This is not our case. Let's go to the geocoder, and in this geocoder, pay attention here. We are looking for US features or word features. Of course, we are looking for word features. So, for example, in the feature name, I can just search for Torino, for example. In all countries, of course, you have more results, so we can refine the search. So I'm searching for that, and I'm asking to show the possible results, and you see here we have many results. For example, we have a couple of places, Torino, in Costa Rica and Russia. Then I have Italy and 3 places of Italy that you see are more or less the same coordinates. This is the 3rd order administrative division, the 2nd order, and the 1st order administrative division. That means that is region, province, and city. Let's, for example, choose the first one, Torino, this one, and you see it's located in the right position. So we can here just zoom in, and you see we are in Torino. Here we have differently from the CHAB for Copernicus, we have images that are, of course, Landsat images in this case. And you see here is not really Torino. Okay, it's the center of Torino. You see here, it's we are in the city where I'm broadcasting right now. All right. So now we need to search for the interval of data. So let's do the same things that we did for Copernicus. So today is the 24th of October when I'm recording this video. Let's start with the 25th of September, and let's go till today. All right. So 24th of October, and let's check it, and you see we have the same month available. All right. Then you see we can also have a possible filter related to the cloud cover. And you see, for example, cloud cover range from 0 to 100%. Here easier to use in comparison with Sentinel. We can just move this bar, and let's say we want images not more than 20% of the image covered by clouds. Then here we need to go to the datasets, because I mean in this portal there are many datasets. So click on the datasets, and you see we have all these things here. You see aerial imageries, AVHRR, that is a very low resolution data, digital elevation, declassified data. Commercial satellites, for example, you see here IKONOS OrbView, but consider that all these data are related to the states, apart from AVHRR, that is a very low geometric resolution satellites, but all the data are only available for the states. So all this data here, also the land cover, a part of the land cover, I mean. While what we need to, you see that there's also Sentinel here, So you see there's also Sentinel-2. So you can also download Sentinel data from here, for example, if you want. But let's use the official portal of USGS also for Copernicus, because I never, telling the truth, I never download data, Sentinel data from here, because I also think that maybe that's not the entire series, but only related to the States, or limited in time. So it's not the case to download data from here. But let's go to Landsat. This is our data. And you see here we have Landsat Collection 1 and Landsat Legacy. Legacy means that our data old, all right? You see, this is the data sets that are available. For example, here you can also download data till to the early 70s of the last centuries. So there's always the possibility to download data that are more or less 50 years old. In order to perform very long multi-temporal analysis. And you see here we have also this possibility. This is TM, this is ATM Plus, and this is the data. TM is on board on Landsat 5, that you see it will be operational for 13 years, from 84 to 97. Then ETM Plus, that is on Landsat 7, that is available from 1999 to 2003. After 2003, there were some miscalibration of the sensor, and the sensor has not been used. These are all ATM Plus data, and is finishing here till 2003 in the Legacy. In the Landsat Collection 1, you see we have the data we are interested in. And some data are on demand. That means that this level C1, the levels are more or less the same that we have. For example, for Landsat 7, Landsat 4 and 5, and Landsat 8, that are on demand. That means that you are ordering the scene, and the scene calibrated is available after a few hours, or after the day after, for example. I think that the limit is 24 hours, and you will be warned by a mail to your account, and that's why you need a valid account in order to be warned about the availability of this data. This is on demand, while, for example, the level 1 is available in real time at C1. C1 means top of the atmosphere and calibration. But the data are still digital number, real integer, positive integer. So for this data, you need to perform the calibration, of course. So let's, for example, search for Landsat 8 data. The sensor you see is not the ATM, the sensor is not called the ETM Plus, but it's called OLI and TIRS. TIRS stands for the thermal infrared sensor, all right? While the other one is the OLI is registering reflection coming from the ground. So optical windows in the visible and near and mid-infrared, the data that we are used till now. So we are searching for that. We can also put additional criteria here. So, for example, these additional criteria could be some here. For example, if you know the path and row of the orbit reference system, you can put that in order not to search for toponyms, but for satellite scene reference. And you can also set other different thresholds. For example, considering the cloud cover, you can select, for example, in our scene that we will download, if we are more interested in land or in all the scene cloud cover. For example, if we are interested, as we are, in the land, if there are there will be a cloud cover over the sea, we are not really interested. So we can set all these things here, and so also all these particular data here that are related to the geometric preprocessing. We are not interested in setting more than these criteria, so we can just click on the results. And in results, you see the results is quite simple. You see we are displaying 4 different images that are downloaded. And you see here the acquisition date of the first is the 23rd of October. The second one, 14, so that means 9 days before. This is the 7th, that is only one week before the acquisition, 7th of October, and the 28th of September. Why there are not other images? Because eventually these images, this is the 4 images that were acquired during that times. Maybe there are others, but that could be covered by clouds, like this one. I don't know why this one is here, because it's completely covered by clouds. For example, I think that, stating that Torino is over there, we can just simply check this one, the image acquired on the 7th of October. Here you have different things. For example, you can show the footprints here. You see, this is our classical image that we already used. This is the footprints of the image. Then you can also browse with an overlay the image. So you see, you will have the image overlaid. I'm taking out these things here. So you see that there are clouds, all right? We already know that there are clouds. And then, for example, or you can order, you put that in a basket and order the scene, because maybe you want you don't want to download right now, because, for example, you are searching with your phone, with your cellular phone, or you are ordering that image, and then you can download later on this image. Or, as in my case, you can download directly the image. So I'm clicking here, download option, and you see here is the different option of the download. So you can download all the data, and all the data is the last one, download level 1 GeoTIFF data, that is more or less 1 gigabytes, or you can also download from the beginning the Landsat Look natural color image, that is only the undersampled color image of these things that maybe can be used for publication or for journalists, for example. Then the thermal image, only the thermal image, because you remember we have also thermal infrared image. The quality image, that is an image that is showing you the quality of the data, and the Landsat Look image with geographical reference, that is, the same one, but with the georeferencing. And then you can download what we are interested in. So we can download, for example, the data we are interested in, so the whole data. All right, so you can see now we have the availability of the data. So I can save this file, and as usual and as before, I will have to wait, as stated, more than 1 hour. So we will meet again after this 1 hour. So see you later. All right, guys, so we did download everything. So let's check what we have in our folder. You see we have this data here. It's of course compressed, so we need to uncompress that. So just double click on that. I'm using WinZip for these things here. All right. Let's go directly to the file. I want to uncompress that file. All right. Okay. So it's going to uncompress that. You see, it's extracting everything. It's more or less 1 gigabyte of data. So let's wait. It's finishing the things. Okay. Okay. They uncompress everything in one of our folder. So let's put that in a new folder. For example, Landsat 8, for example, all right, in this new folder. So we are opening that, and we are extracting everything here. All right, here it is. So we can close everything right now. Let me check if it's working. I'm sorry, I need to check it. Okay, Landsat 8, and you see we have all our images. All right. And these images, you see, we have the different bands, band 1, 2, 3, 4, 5, 6, 7, 8, B8, B9, B10, B11, okay, with another file, this one, BQA at the end, that is the quality assessment file. Here we have some, and the first one is a sort of text file where you have all the information, and then you see we have the MTL file, that is the metadata file. All right, so we can close everything. Okay, let's close it. Let's go again to Envy. Okay, in Envy, you remember we were in that situation. We did open the Sentinel data. So we can close that, and now we are going to open the Landsat as usual, as open as optical sensor, Landsat GeoTIFF with metadata. All right, let's go to the download. We need to go back to the original folder. Okay, you see here we have Landsat 8. I forgot an A here. All right, this is the metadata file. You see, we can open that, and as usual, here it is, the file, you see, this one, and we have the visible, you see, this is Torino. So when we are going to the data manager, at the end, we will find everything as usual. We have the Landsat 8 data opened, with the first data set that is encompassing the first two blue bands. The first that is called coastal aerosol and the blue band, then green, red, near infrared, middle infrared 1 and 2, and then you see we have the panchromatic, and we have also the couple of thermal infrared here, and here we have also another mid infrared file that is the Cyrus one. All right, so you see we have all the data, and we have also the quality data. Okay. You see, so I don't need to explain more about this file. You see, this is the original file. You see, this very cloudy, so I feel that I cannot use that. And you see, under that we have also all the other files that we download. For example, the 60 meters file that I can just gave up from the visualization, but you see this is the footprint of the two different images. You see, this is very cloudy. I cannot use that, but just to tell you how to download. There's nothing more to say, because you are used to this kind of Landsat file. We use that in many labs, so there's really nothing to say. All right, so in this way now you are able to download data, free open source data, both from Sci-Hub portal and regarding Sentinel, and you are also able to download thematic mapper, or better, Landsat data. So this is how you can do that. So for today, that's it, and I will just give you other information concerning other possible things you can extract from this data. So that's it for today, and thank you for your attention. Take care and never give up. Bye-bye.